webinar. And our topic today is correlation versus causation. I'm Lorraine Jackman. Janelle Mills is the other secondary education associate. And
I'm Dawn Hood. I'm the middle level education associate, trying to let people in. Sorry.
Love you. Bye.
All right. So correlation versus causation is what we're going to talk about today. So welcome to our webinar. So we do have a disclaimer on the use of artificial intelligence. The content,
I'm just not logging in. Sorry.
the content presented is the intellectual property of the South Carolina Department of Education. By participating in this event, attendees agree they will not record, capture, or share its contents without permission. Attendees agree they will not use artificial intelligence, AI, to capture or summarize the contents of this event. The SCDE reserves the right to remove attendees using these services. So if you have that going on, please go ahead and remove yourself, or we will. Okay. All right. You want to go with our purpose?
so let's take a moment to read this quote. Geometry is the beauty of mathematics where you can actually visualize and compare it with real world. Archimedes. So take a moment to read this quote, and as you do, I want you to think about how this connects to the work we're going to be doing in this webinar. The focus is to demonstrate strategies to introduce the HQIM resources to teachers and to encourage using these materials to provide instruction to students. During these sessions, content will be discussed because this may be the first time some teachers have taught geometry or statistics. And while some may be comfortable with the content, others may need of more support. So our purpose today is to train teachers, coaches, and support staff on ways to utilize highly qualified instructional materials with the 2025 South Carolina College and Career Ready Geometry with Statistics Mathematics Standards. That was a mouthful. Our second purpose is to equip teachers and support staff with strategies to facilitate instruction of the 2025 Geometry with Statistics Math Standards. And our third purpose is to demonstrate instructional strategies that promote student engagement and conceptual understanding.
All right, our agenda for today is we're going to focus on GS DPSR 2, mostly 2.1, which is also located in our 8th grade compacted, and our related 8th grade indicator is 8 DPSR 1.1.
So let's talk about today's standard and indicators. When you read this indicator and standard, what resonates with you? I'll give you a moment to read through that. Think about what keywords tell you what students should be able to do after learning this indicator.
See in the chat, analyze and interpret models. Is that someone coming off and speaking in? Speak louder. Analyze and interpret.
Preferred models. I think students should be able to compare and.
Contrast
Okay.
different models. Mhm. And this is the standard. This is the overarching big piece. All right. So when we look at the indicator itself, it's a little more specific. We're going to distinguish between correlation and causation.
And that will be our focus today. And the insight gives us how we can teach this. So, and things that we should be looking at. So we're going to explore some possible reasons for an association. Predictor causes response. Response causes predictor. Lurking variable or random occurrence.
Click the right thing. We'll get started.
Hmm.
All right. And we also have some math process standards that kind of work in with these. And you can see representation and communication, connections, and then analyze and justify kind of fit with what we're going to be talking about today. All right, correlation versus causation. So the key to the definitions are in the word. In correlation, you can see the word correlate. So that lets us know that we will be looking at two events that are related. In causation, you can see the word cause, and that lends itself to the people coming in getting me. So it lends itself to the definition of one event that causes another. Okay. All right, so let's look at some examples on the next slide. So if we were to discuss this, I want you guys to think very carefully about how you would answer this. And if you see down at the bottom, we have a smiley face for correlation and an upside down smiley face for, I can't even talk now, for causation. To find those, they're in the chat. So if you go into the chat and then you see in the box where you type in your chat, you see the smiley face down there. That's where you can get to these emojis. So if you click on that, I can't get my mouse back to where I want it to be. And you open that, you'll see a list of emojis. And then you can, from there, find the upside down smiley face or the right side up smiley face. Okay. So for this first situation, healthy eaters and ice cream sales, if you will think about which one of those it would be a correlation? Would it be a causation? It's possible it could be both, and you would just put both smiley faces together. But if you'll type in the chat which one you think it would be, and then we'll hit send all together. So when I say go, I want you to hit send. So I'm gonna give you a second to find them. If you have a question, you can come off mute and I can help guide you towards those smiley faces again. So get ready. And let's go for this first situation. Would it be a correlation or would it be a causation? Look at all these smiley faces coming in. Come on, I know there's more than 5 people here. Let's go. All right. We're going to be asking you to participate a good bit today. So please, please join us in this. It'll make it a lot more fun for you if you're actually a part of it. Yes, we are talking about a correlation here. Now let's talk about what a correlation really is. What makes this a correlation? Does anybody want to come off mute and answer that? Or you can type it in the chat. Why is this a correlation? Healthy eaters won't eat much ice cream, so sales will decrease. Those who eat healthy aren't necessarily eating ice cream. Okay. Ice cream has lots of sugar. Absolutely. That's one of the things they told me to lay off of, which is fine for me, but not for my husband. Ice cream sales will be down due to healthy eaters not buying. One does not necessarily cause the other. Good. There may be a relationship, but one doesn't actually cause the other. Oh, right. All right, you ready for the next one? Same thing. We're going to do the smiley face for correlation, upside down smiley face for causation. If you think it could be both, you can put in both. All right, so our next situation. Now hold on to it. Don't put your smiley face. Don't hit send until we're ready, until I say go. All right, let's talk about temperature and shivering. Temperature and shivering. Get ready with your smiley face. Put it in the chat and go. Upside down smiley faces. Brownie face, we'll take that one. All right, so it's a causation. So can you explain why it would be a causation? Put it in the chat or come off mute. I like the frowny faces. These animated ones are so neat. Low temperatures cause shivering. The body shivers in order to return to normal temperature. Low temp causes shivers, yes. It's a cause and effect relationship. Good, good. Now, according to this though, it's both. What do y'all think about that? Why is it both? I wasn't even looking at my notes, but I know that the lower the temperature, the higher the amount of shivering. So how is it both?
Because there's a relationship and there's a cause and effect. It's
Perfect.
both.
All right. All right, our last scenario, working more hours and higher paychecks. Will it be a correlation, a causation, or both? All right, go ahead and put your answers in. See what we got. Uh-oh, we got some of them are saying a correlation, others are saying causation. Some put both. We've already got some justification in there. Salary pay doesn't get more money or more hours. Let's think about it from a teacher aspect. The more you work, do you get paid more? So this one could be both, but I think it's more of a causation than it is anything else. Because of the fact that you could have a job that is salaried like teachers, and you wouldn't get more money based on how much you worked. But if you're a salary employee, you get paid by the hour, then you would make more money. So it wouldn't be, I wouldn't say maybe together both, but it could be one or the other based on a situation. Do y'all agree with me? Lorraine, you can jump in.
Well, also too, I mean, you're working more hours, just like someone just said there, if it's hourly worker, then yes, you would get higher pay.
Yeah, that is not the teacher way, is it? Too bad it's not.
No.
All right, so let's go on to the next piece. Let Lorraine work on this one for us.
Okay, so suppose there is a strong positive relationship.
You want me to click?
Well, actually, yes, click that part first. All right, so we're going to be looking at predictor causing the response versus response causing the predictor. So we have hot chocolate and small marshmallow sales at a grocery store increase during the winter. And increase in the hot chocolate sales, marshmallow sales causes the marshmallow sales to increase. So suppose there is a strong positive relationship between hot chocolate sales and small marshmallow sales at a grocery store during the winter months. An increase in the sales causing the marshmallow sales to increase. So what do you think? Would that be a predictor causing the response versus a response causing the predictor? You can just put your answers in the chat. Predictor, cause, and response. We have 1 or 2. Hot chocolate and marshmallows follow a sort of trends. Okay. I can't see all of them. You can read it for me. That'd be
So hot chocolate and marshmallows follow a sort of trend, so I'm going with response causing the predictor.
Okay. So we have 2 different viewpoints.
And then somebody thumbed up that one.
Okay.
All right, so how do we feel about this one? Let's see. You ready?
Yes. So the answer is actually the predictor causing the response. And let's look at another scenario.
Let's talk about why.
Okay.
Why is the predictor causing the response in this one?
So we have, I'm not a hot chocolate drinker.
Therefore, that's why I said it's a trend.
Okay.
I tend to
Yeah.
drink more hot chocolate when it's cold.
Yeah.
So I see the increase during the winter for sure, because more people would drink the hot chocolate in the winter.
All right. And then some people like marshmallows in it. So,
I like it both ways, either way.
okay. All right. So here's another scenario. Number of hours of sleep versus hours of exercise. So we could create a scatter plot that shows the number of hours of sleep a person gets correlates with increased exercise. And the sleep does not cause the increased exercise.
So would this be the predictor causing the response again, or response causing the predictor? We got Christy saying response causing the predictor. Anyone else? Or if you agree, you can always put a thumbs up. Response causing the predictor, again from Julie. Thumbs up.
Exercise is a life choice. Not sure. Okay. Then it's gone.
All right. So for this one, we're saying response is causing the predictor. So let's talk about why.
So this,
If response is the number of exercise, then I agree. Okay. So hours of exercise versus number of hours of sleep. So she's saying if the response is the number of hours of exercise, then she agrees. Okay.
now, the example above is a predictor causing a response. And when you're discussing this with your students, there's an opportunity to also discuss random occurrences and lurking variables. So random occurrences are situations with no cause and effect relationship. An example of this lurking variable would be if the number of snowboard rentals increased during the same months. This does not mean that an increase in rentals causes people to buy more hot chocolate, nor does it mean that increased sales of hot chocolate cause people to rent snowboards. There is a third variable, such as the cold weather, that might be causing both variables to increase during the same time period.
And when we're looking at the sleep versus hours of exercise, I think the focus there is that if you exercise more, then you might sleep better, therefore sleeping longer, hopefully. Maybe I need to work on that myself.
Although with some people, they find that if they exercise more, it gives them more energy and then they don't sleep as much.
Marie is asking if there's a specific question we asked her to determine which is cause and which is predictor. Do you know that? Right, because I don't.
If there's a
specific question that we asked to determine which is the cause and which is the predictor.
Not that I can think off the top of my head right now.
But we're gonna write that down and we will answer. Janelle probably would have the answer, but she is not able to be with us today. So we'll talk to her and we'll get you a response, Marie. All right, we might even talk and have it before this afternoon. So Michelle's asking, like, how would you present these two concepts to students, the difference between the two? So I would think is the focus on which one is the response, which one is the predictor. So if we're talking about hot chocolate sales increasing and the marshmallow sales are the response, because marshmallow sales are increasing as well because there's more hot chocolate being bought.
Right.
And people like marshmallows and small marshmallows in their hot chocolate, unless you buy the stuff that's already got it in it. And when we're looking at number of hours of sleep versus hours of exercise. So I'm thinking the first thing is the predictor. And then the second thing is the response, the way I'm looking at it in both situations. So if we're looking at the number of hours of sleep being the predictor, how much sleep, you're going to get more sleep or maybe less, depending on how you want to look at that. So we really probably needed to define that one. And then your hours of exercise could be increasing, allowing you to sleep more. Yes, it's important to establish which variables, which before students can distinguish which answer applies. So I would focus on, if you're going to give them a scenario, make sure they know the predictor is going to be what's coming first, and then the response would be what came after. Right. So let's talk about some specific things. We know that the textbooks are out there, and we need to focus on what you're going to be seeing in your books and how to apply the learning. So we've picked a learning target from Accelerate Learning, which is Math Nation, and we're going to look at a specific example from them. So if you know the standard and indicator that we're focusing on, let's look at our learning target today that we would, and what would we expect our students to be able to do by the end of this lesson that would show mastery? So if our learning target was to recognize connections between two variables in order to analyze whether or not there is a causal relationship, what should we expect students to be able to do by the end of that lesson?
That would show mastery.
Yes.
So in the chat, or you can unmute. You can put in your response.
So what is our focus for students? Let's see, Julie asked us a while ago on the last slide, couldn't we just ask, does one predict the other? And they could talk about
You can.
that question too. I like that.
Mm-hmm.
See, I'm learning just as much as everybody else. Identify if two connections are related. Okay. Just related? Because if it was related, we'd be looking at correlations. And we're trying to analyze whether or not there is a causal relationship. So I think we're going a little bit deeper than just related, but that's the beginning, Crystal. Okay. Anyone else? And to determine if one causes the other, yes. I think that kind of sums it up. If students can answer that, then they should have mastery. All right, so the launch in Math Nation is this right here. Describe the strength and sign of the relationship you expect for each pair of variables and explain your reasoning. So as we go through these examples, we're going to use a waterfall protocol, and you're going to place your answers, your responses in the chat, but don't hit send until I say go, like we've been doing so far. Okay. So what we're looking at here is used car price and the original sale price of the car. So what I want you to do is to think about what kind of relationship it has. Is it strong or weak? And I want you to put that in the chat, but I want you to hold on to your answer until I'm ready for you to put it in, because I have another question for you as well. So not only are we looking at just strong, we're looking at whether or not it has a correlation or not. What kind of correlation? Okay. So if you'll type that first one in there, is this a strong or is it a weak? And go. Strong correlation. It has a positive correlation. You're jumping ahead, but that's okay. So it is strong and it is positive. Good job, guys. All right. So for the second one, I just want you to do one or the other, strong or weak. And then we'll talk about whether it's a positive or negative or no correlation after we talk about whether it's strong or positive. Okay. Because I want you to hold your answers until we're all ready to put something in. All right. Second scenario. Used car price and number of cup holders in the car. What kind of relationship do you expect? Is it a strong one or a weak one? Type it in, but don't hit. Oh, y'all hit too soon. You were supposed to hold on to that answer. Hold it until I was ready. All right. So now let's hold on to our answers. Is it a positive correlation, a negative correlation, or no correlation? And some of y'all are already answering. So we got the weak, and then no relationship or no correlation there. All right. I'm glad to see everybody participating though. All right, third scenario. Y'all ready for this one? Again, hold your answers till I'm ready. I'm gonna start sounding like the woman in the CarMax commercial going, hold. All right, used car price and number of miles the car has been driven. All right, would that be a positive, sorry, wrong one, strong or weak relationship? Type it, don't hit go yet, don't hit it. Hold on to that answer. All right, and then let's go ahead and add the second piece in since everybody wants to anyway. Is it a positive correlation, no correlation, or a negative correlation? So hold your answer still. You're going to have two answers. Ready, go.
True waterfall.
There we go. Strong negative. Look at everybody. I learned a lot by going through this PowerPoint with Lorraine this last week, since we knew Janelle was going to miss out today. So we taught each other on Friday, I think. Good job, guys. Thanks for participating. Oh, let me give you your answer. There we go.
Yeah.
All right. I've gotten so excited now, I don't remember who's next. You want to do this?
Okay.
Got it. All right.
So for this section, we're going to be looking at some scatter plots with some line of best fit. So during the month of April, Elena keeps track of the number of inches of rain recorded for the day and the percentage of people who come to school with rain jackets. Sorry about that.
All right.
Yeah.
So the question is,
What is the association between each set of variables? Can you describe the association using the correct vocabulary terms?
you can type your answer in the chat or come off mute.
Mhm.
We can do waterfall if y'all are liking that. I mean, like y'all were waiting. I think y'all were waiting on us to say go.
Mhm.
As the precipitation increases, the number of rain jackets worn to school also increases. Do y'all call them rain jackets or raincoats?
Oh, yeah,
We had that-
debate on
We did have a debate on that one. Strong positive correlation. Strong positive relationship with causation. Right. One usually does cause the other. Unless, it's a quick downpour like we have down here. And then it's gone before you even leave for the day. So,
Okay, so yeah, so that first one, it is a linear association, a positive linear.
all right.
All right. Now let's look at the next one.
Can you predict what it's about?
Okay, yeah. Can you predict what this one is about? We have number of pages and time in hours.
We see that it is definitely a strong positive correlation. Any thoughts what this might be about? Can you give it a title? Hours you read a book and the number of pages read.
Okay.
All right, let's see. I'm sure you're right.
A school book club has a list of 100 books for its members to read. They keep track of the number of pages in the books the members read from the list and the amount of time it took to read the book.
In the relationship you see, using correct vocabulary terms, we've already seen some strong positive correlation on there. I have a question. Why is there that space between 0 and, what is that, 2 hours? Anybody know? Why is there that blank space before it starts? It doesn't start at 0, 0. Half hour. Actually, it's like 2.5, and if we look at the dots, not the line. Maybe.
Because you can't read a book in less than 2 hours?
Mhm. Number of pages, though, is what they're looking at, so.
No one read in the first 2 hours. Okay.
None of the books had less than that number of pages, so it took that
Oh.
long to read.
Okay, that's a good thought.
Mhm.
Hadn't thought about that one. Okay. All right, good questions to ask the students, right? What do they see? Tell us more about what you see instead of just what's face value. All right, you ready for the third one?
Yeah, and even before that, so a lot of times, so with this, most people are used to seeing the independent variables on the x-axis and the dependent variables on the y-axis. So the convention is to put the causal variable on the x-axis and the other variable on the y-axis when one of the variable does cause the other to change. But the book club scatter plot could have the axes switch to meet this convention. Because one is causing the other. All right, let's look at the third one. So what do you think with this one?
I'm sure you can tell us what kind of relationship you see first. Let's start there.
Okay, yes, it is negative correlation, but what do you think the situation could be?
This one's tough. People at an event and the noise level. Look at that. Did you see it already? Tickets to a concert and noise level, yes. Less tickets equals quieter audience. Good job, Gail. That's exactly what we were discussing when looking at this one. It's a holiday party instead, but still all the same type of event.
Yes.
All right. So we were talking about trying to explain it, and I kept saying, wait, what I'm saying didn't fit
What you thought it was.
what the actual correlation was.
Mhm.
And so we had to make sure we were saying it right because of the less tickets equals quieter audience is exactly what we came up with. All right, good job, guys. All right, so just so you know, Savas is another, well, I know you know this, Savas is another textbook, but when their complete or their South Carolina lessons are in the book, they're actually at the back of the book. especially for, well, you can find them very easily in the table of contents if you're online, but the book itself, it has it at the back. So,
And when you're online, you can also look at the correlation directly with the standard and indicators.
so we're looking at SC1, which is the first lesson for South Carolina that is exclusive for South Carolina. And the goal for this lesson is to blend conceptual understanding and application together. And students will analyze the relationship between two variables by observing association, causation, or correlation. When we looked at this one, we noticed that it also incorporates DPSR 1.1 and 1.2 from the geometry standards. And it suggests that you teach this concept after lesson 2.4, which is parallel and perpendicular lines. So students will have already analyzed the slopes of parallel and perpendicular lines and written parallel and perpendicular linear equations for a given line. And then you can link back to your lesson if you include the writing the equation for line of best fit. And then this lesson will lead into algebra content. But for the piece that we're talking about today, we're going to focus on just the correlation or causation piece of it. So this is just a true or false. So if we'll do the waterfall again. So if you'll just put true or false in the chat, and then when we're ready, we'll say go. Okay, so do you think a scatter plot that has a negative linear association shows an increasing relationship between both variables? Is that true or false? Can you explain the difference between correlation and association? Let's see, I'm gonna have to take a second for that one. All right, so
Is that a question?
yeah, that was a question. Amy is saying things that can be associated and not correlated in statistics. I've seen it used interchangeably. I have two.
Well, you think about the term correlation has we can actually calculate that with a number, but the term association is more broad in terms of relationship.
Okay. Thank you for
So
that.
if you have to quantify an association when you're talking about correlation, I think.
Okay. All right. So correlation must be linear is what Amy put up as well. Thank you guys for all the answers to that. I know that we're supposed to be the experts in this, but I am not. I can tell you that. I have not taught geometry. So I'm learning just as much as you guys and going through this. Now, Janelle is our expert. And like I said, she couldn't be with us today. So unfortunately, so
Statistics, but yes.
so yeah, we're trying to do what we can with this today, but
Okay.
we're having fun with it already. So I hope. So we're ready. Are you ready for true or false? Put your answer in the chat and go. True or false? I see a false, 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 false. Everybody's saying false. So do we agree? Ta-da, yes. Y'all are great. A scatter plot that has a negative linear association shows an increasing relationship between both variables. That's pretty straightforward right there. Okay. All right, next piece. Ready? A scatter plot that has no association can have an increasing or decreasing relationship between variables, true or false. So get ready. Think about this one and go. How do you feel? See a true, 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 true.
I guess explain.
Yeah.
Yeah.
Because help us see what you're thinking about, because I was thinking false on this one. Because if they have no association, could they both be increasing or decreasing? I was thinking one had to be one or the other, like they were all over the place for no association.
I was thinking false also to begin with, but then the way I reread it, and because you said it can have an increasing or, it's kind of like the idea that it could be either is the way I read your statement.
Okay, this statement actually comes from Savas.
Mhm.
This was an activity in that lesson.
I guess the focus should be that it has no association.
Mhm.
So you're looking at basically a line of best fit that would just
Well, there
be
wouldn't be one,
horizontal.
right?
Right.
There wouldn't be one. So I guess I'm thinking maybe the or there is just saying a scatter plot that has no association can have an increasing relationship or a decreasing relationship.
Zero.
So maybe it's the way that they wrote it that makes it a little bit more confusing.
Mm.
So we may have to look at that one. Okay, so technically the correlation would be 0 with a slope of 0, so I guess it's neither. So
It's
yeah,
not
you're right,
clear.
it's not
Yeah.
clear. So we may need to look into that. That's like I said, this came straight from Savas. So all right, so let's look at the third one, see if it's any easier to understand. A scatter plot that has a linear association must have an increasing or decreasing relationship between variables. There's that or piece again. So I'm not sure if this is any better. Maybe within the lesson, there's enough description that they use that would help make this clearer. But for this one would be true.
And
That's
then
the honest truth.
going back a little bit, how could you make the first statement true? We'll ignore the second one since there is a
This one
discrepancy
says
with that.
must have. The
Okay.
last one said can have. You're right, must have versus can have. So that might be the biggest piece right there. Okay. Clearing out the words. Yep. Got to look at the words, the wording.
Mhm.
Like Lorraine said though, how can we change the first one so that it could be true? Change it to positive linear association, change increasing to decreasing.
Okay.
Mm-hmm. All right, good job, guys. All right, so we've gotten to our part of our webinar today with some breakout rooms. We're going to go to some breakout rooms real quick. We're not going to spend but maybe
10 minutes.
I think less probably, but
Yeah.
yeah, because we're running short on time.
Mhm.
So about maybe 7 minutes in there, and you're going to create or complete the Venn diagram that's given. I'm going to drop a link in the chat to the Google document. And so whatever room you end up in, match it to the Google slide. And you guys are going to come up with your own examples
Mhm.
to fill this Venn diagram. Okay, so the Venn diagram is correlation, no correlation, which are your two bigger circles, right? And causation is in the middle of one. Okay, so.
And also make sure you choose one spokesperson from your group.
Mm-hmm.
And please make a note of which room you're in. Because sometimes when we bring you back, everyone's like, I don't remember what room I was in.
All right, let me see. We've got 29 people. How many rooms we
6
want?
rooms.
5, 6 rooms? Okay. I think we only have 5 slides, so I'm going to
Okay,
go back
so
to
then
5.
Mhm.
Create rooms. All right, and all right, you guys have been assigned. I'm going to open the rooms and send you there, and then I'm going to drop the chat, the link into the chat. But we're running low on time for the meeting. We don't want to hold you over. So we wanted to bring y'all back and just kind of talk about what you did in your breakout rooms. Just give us a quick thought of what your examples were. So we'll go through our rooms. So room 1, do we have our spokesperson to tell us about what you guys talked about or what you came up with? Mhm. Room one.
I'll go. We talked about a correlation was the number of hours that a student studies for a test in their test grade.
Okay.
We said a causation could be the number of days of math class a student misses and their grade in the class.
Okay.
And then a no correlation example was we said a person's height and their IQ.
Fantastic. All right. Group 2, tell us what you talked about.
So I'll go for room 2. I think one key thing, and just I put it on a sticky note on my computer. All causations have correlations, but not all correlations have causations. So just keeping that in mind. So no correlation. We had IQ and shoe size. And then our causation was smokers have an increased risk of lung cancer. And correlation was ice cream sales and the number of shark attacks.
All right.
Like that one. Ice cream sales and number of shark attacks. Great.
Group 3. I popped in and heard some of this going on.
So we didn't quite finish, but what we do have, we have for causation, we have water drink with trips to the restroom. And no correlation, just lifespan of a dog versus lifespan of an elephant.
Okay.
And we didn't finish for the correlation.
That's okay. That's all right.
Great, thank you.
Group 4. Oh, we're talking about sharks too. What's going on about sharks? Is it Shark Week?
I'll pipe in. The biggest thing is that that's a classic example used in AP statistics, the
Okay.
shark attacks and ice cream sales. And we also had the shoe size and IQ. We weren't trying to copy group 2, but we may have people who have similar history with things that we've taught. And then running and heart rate. But I do like the person who spoke up and said causation will have a correlation, but correlation is not necessarily causation. That was a good find.
Observation or explanation. Yes, absolutely. Thank you. All right. Group 5.
How do you do that?
If somebody's talking about it, we can't hear you. Y'all can probably see it. Causation is heart rate and running or walking. And then no correlation was test score and shoe size. All right. Let me get back to the PowerPoint. And we are about to wrap up for the day. Or this, not the day, but this. So I hope we've helped you some today and getting the difference between correlation and causation out there for you. If you have any questions real quick, we can try to answer a few.
If not, we'll try to answer it by the second webinar.
Yes, you can
Which is
submit
later
it.
today.
You can submit your questions to us. You can email us or you can submit them through the form that you signed up with. And if not, we're going to move on to the survey for the end of our webinar. But I don't want to rush. So if you have questions, go ahead. Nothing in the chat yet. So let's go ahead and go to the feedback survey. Lorraine has put this feedback in the chat. So if you want to just click on it, you can do it that way. And our formal reflection is just that we ask you to take a moment to complete the survey. It helps us determine what needs were met today and what we can touch base with you about later and make sure we're supporting you as best we can.
Yeah.
So the link that you're asking for, Michelle, I think it should be right above it where Lorraine put that in, if that's what you're asking for. She put it in again. If not, if you want the questions link, then just let me know.
Oh, okay, just making sure. It's fine.
Thank you all for participating today and being a big part of helping us do the webinar. I feel like participation today was fantastic.
You're a great group.
We do have office hours tomorrow. Elementary,
Have a good
middle,
day.
and high have office hours tomorrow. So if you want to join us, I think elementary starts at 3, middle is at 3:30, and high school's at 4. So just plugging for our office hours tomorrow. Right. So once you complete the survey, thank you, and please let us know if there's any questions, anything that you need us to do for you.
Are the office hours tomorrow for the PAFR session?
Yes.
Okay.
It is the PAFR session tomorrow. For those of you that missed the previous webinars, the recordings should be coming out soon. So just keep an eye on our
The very-
PLO page.
Yeah, the very first one,
Should be posted.
it should be posted.
But the second one, we're still working on the recording, making sure it's ready to go to